We'll now go over how to write up a lab in your notebook. This bullet list outlines what elements have to go in the lab report, but I will show you examples as we go through this. To begin with, you start on the top of a fresh page and you write down the experiment's title, the date, your name, and your partner's name. So it would look roughly like this: title, date, name, and partner's name. The next thing that goes in is the objective or goal. This is just a few simple sentences saying what you're trying to accomplish in that week's experiment. A lot of the experiments have a goal in them, and you're welcome to copy that. Again, this is what it looks like, just a simple sentence saying what you're trying to accomplish in that experiment. The next thing to include is references to any outside materials that you used, like a website or a textbook. Usually you don't need to include anything because the only thing we're using is the lab manual. The next thing you do is you perform your experiment and record your data. Now, one thing that I'm very picky about is that you need to label everything fully. Here's what I mean. In the procedure section of an experiment in the lab manual, you'll see numbered steps. So step 10, do this, step 11, do this, and so on. It's very common when students are writing up their experiment to just write down step 10 and then the calculation or the data, step 11 and then the calculation or the data. This isn't enough. You have to label every calculation and set of data in words. The number by itself is not enough. Likewise, when you write down a single item of data, make sure you label it in words, not just the symbol, and every number should have its units written down with it. That's just part of complete labeling. And while I'm here, I'll just point out that in your lab notebook, you have to show every calculation. So you need to show every calculation in full detail. Even if it's a really simple calculation, like one number minus the other, don't do it in your head. You do need to write out the full calculation in detail for your lab instructor to see. Now, when you have repeated or related trials, you probably want to record your data in a data table. So here's the example, and as you can see, it's got a nice informative title, and all of the information that we would have written down for a single item of data is now written down in the table heading. So they label the measurement in words, they put down the symbol, and the units. Now you'll remember that I told you had to show every calculation you do. In a table, if you've got a column where you're doing the same calculation on every row, you only need to show one sample calculation. So the rest of them you can just fill in the numbers, but you do need to show one sample calculation for one of the items in that column. Now going back to that bullet list, the last thing that you put in your lab write-up is an analysis of your results, but I'm going to defer talking about what goes in the analysis until after I've told you about the concept of percent discrepancy. Before I do that, though, I'd like to first talk about one last thing having to do with your lab notebook. A scientist's notebook is a legal document. It's supposed to be a permanent record of all their work. And in order for your lab notebook to be a permanent record of your work, there's a couple of rules we need you to follow. They all basically boil down to the idea of never obliterate information from your lab book. So to begin with, you must write in pen only. You can use pencil for graphs, but generally speaking, your lab notebook has to be written in pen. Second, you should never tear pages out, you should never use whiteout, and you should never scribble something out to the point where it can't be read. If you need to make a correction, put a single line through the error and then write the correction nearby. The point is that both the error and the correction are still readable. Remember, your lab book is supposed to be a permanent record of everything you did, including mistakes, so even the mistakes should still be readable. Another thing you should be aware of is that you should never write data on a piece of scrap paper with the intention of then copying it into your book neatly later. All of that work should go directly in the book as part of your permanent record of your work. So if you do want to do some rough work, just put it on the back of a page and label it rough work, and your lab instructor will ignore it when they're marking. So rough work is allowed as long as you put it directly in your lab book. And finally, I just want to assure you that messy is okay. Your lab book can have things X'd out, comments in the corners, arrows running all over the place. It's okay if it looks messy. All we care about is the quality of the science. So don't spend any time trying to make your lab book look perfect. Just make sure that it's readable and complete. In the sciences, it's very common to want to compare two values to see how well they agree with one another. And one of the ways to do this is by calculating what's called a percent discrepancy. The formula for doing this is given here. You subtract one value from the other value, ignoring any minus signs that crop up, and then you divide by what's called the best value and multiply by 100 to turn it all into a percentage. The definitions for what's the best value are given below the formula. If one of your values is an accepted value, that is, it appears in scientific literature or you've got some reason to trust it more than the other one, if one value is accepted, then that's what you use as your best value on the bottom of this formula. However, if both of the values are measured values, things that you measured, and you've got no reason to trust one of them more than the other, Then you calculate the average of those two values, and that's what goes in the bottom of this formula as your best value. So here's an example of that. You've got two numbers and you want to compare them to each other to see whether they agree well. So you start calculating the percent discrepancy. You take one of the values and you subtract off the other value from it. But then comes the question of what should be your best value. Now, if both of these were measured values, then I would take the average of the two, and then I'd use that as my best value on the bottom of the expression. However, one of these is actually a known value, which means that that's the value we should be using as our best value on the bottom of the expression. Note that the known value appears both on the top and the bottom of the percent discrepancy. So then we calculate our percent discrepancy, and what does this value actually mean? Well, the point of a percent discrepancy is that if the two values are in good agreement, that number is going to be small, and if the two numbers are in poor agreement, it's going to be big. The benchmark that we use in this course is 10%. So if the percent discrepancy is 10% or less, we say that our two values were in good agreement. If it's more than 10%, then we say that the values were in poor agreement. This gets used in your lab write-ups analysis section. So the very last thing that goes in your lab write-up is your analysis section, where you summarize your results and say what they mean. There's generally only 3 things that you need in your analysis, so I'm going to go to a handout now which summarizes these. The first thing you put in your analysis is a summary of all your important results. These often come in pairs, a theoretical value that you calculated and a measured value that you're going to compare to the theoretical value with a percent discrepancy. The example here is based on the parallax experiment, which you will be doing. So to summarize their results, they simply say the measured distance to the ball using the tape measure was this value, and the distance to the ball using the parallax method was this other value. So they just summarize their important results. If your two values were compared to each other with a percent discrepancy, then next you would list that percent discrepancy and explain whether it indicated good or poor agreement between the two values, which is what they've done here. They say the percent discrepancy was 1.35%, that's less than 10%, therefore our two values are in good agreement with each other. And the last thing you include is to say what that good or poor agreement means. So often the conclusion you can draw from good agreement is that the technique that you use to take that measurement is accurate. And that's what they've done here. They say because our two numbers are in good agreement, this means that the distance to an object can be accurately measured using parallax. So in summary, the 3 things you need in your analysis are, first of all, to list your important values. And if you compared any of those values with the percent discrepancy, to list the percent discrepancy, to say whether it was good or poor agreement, and then to say what that good or poor agreement tells you.